Hello everybody, welcome once again to Arduino for Amateurs. This is episode number 17. We're going to talk about the LCD1602 display. So this is an LCD that you can use for output in your circuit. We're going to talk about the hardware requirements, how you wire it up, and then a little bit about the software, how we make things appear in it. As always, my name is Matt Gracie. I'm a hacker from Buffalo, New York. I'm a member of the bithaven Hackerspace. And like I said, what I'm talking about today is the LCD1602 LCD display. 1602 is a really common display. It gets its name because it has two rows of 16 characters apiece, hence 1602. But the principles that we're going to talk about today are applicable to other LCD displays, other character displays of different sizes. So they're all going to be pretty much the same library, the same means of interaction. This is what an LCD 1602 looks like. This is actually two of them. This one is showing the display side. So this is the actual LCD display here. It's got a backlight in it. And then this one is just showing the underside. As you can see, it's got a 16-pin interface here. That's a lot of pins. They all do particular things. But basically we plug this into our breadboard and then we use DuPont wires or jumper wires to plug everything from here back to our Arduino for programming. So this is the pinout for those 16 pins, right? So we got 1 through 16 right here. You can see the names of them right here printed on the top of the display board. So I'm just going to go from left to right here. I want to say before I get started that this picture, as you can see, came from lastminuteengineers.com. Lastminuteengineers.com had an excellent write-up on these LCD panels. I used it a lot while I was preparing this video. So definitely go check them out. There's some more stuff in there that I'm not going to have time to cover, so I think you'll find it very interesting. All right, so pin 1 is the ground and pin 2 is power. These are the ground and power hookups for the LCD panel, right? So the way an LCD panel works is you have a backlight, like a bright LED that is shining through a darker surface, and then that surface has sort of a matrix in it, a liquid crystal matrix where you can cause it to go clear or opaque, and the light shining through that is what causes the characters to appear, right? So this is the power and ground for that LCD portion for the liquid crystal display itself. This third pin here, the one that's marked as VO, this is a pin that sets the brightness, the contrast for the LCD, basically how dark or how light it should be. RS is register select. That's a pin that determines whether the data coming into the LCD unit, into the 1602, should go into the data register. That is it data that's going into the device, or should it go into the display? Is it control data, or is it data that needs to be shown on the LCD? Right, there's a register that determines which sort of memory buffer it goes into, and that's what's hooked to pin 4. Pin 5 is read-write. So this is kind of a weird historical, appendix of a pin. It doesn't really do anything, at least not with the current Arduino library that we're going to be using today. But what you can do with pin 5 is you can put it in read mode and pull data out of the LCD unit. So if you want to store a couple of bytes in there, or if you want to read the content that's currently on the screen, you can pull that information back to the microcontroller that you're using. That operation exists in the hardware. It is possible to do, but it doesn't exist in the liquid matrix library, which is the library that we're going to be using. From what I've read, you can activate that read-write functionality if you use a lower level driver for the LCD control chip itself, as opposed to using the easier Arduino library. So it may be possible to stash information in one of these units and then pull it back later if you need to. But we're not going to do that today, and you'll see we don't even have that wired to anything. We just wire it to ground. EN is the enable pin. So what that does is it takes the data that is in your data pins, which we'll talk about in just a moment, and latches that into the data area in the LCD unit. So this is basically what governs the importation of data from the data pins into the LCD unit. 7 through 14, you can see here, these are the data pins. The LCD panel can take data one of two ways. You can either feed it 4 bits at a time, what's called a nibble, or 8 bits at a time, which is a full byte. Either way will work. You can wire up 4 pins or you can wire up 8 pins. The advantage to 8 pins, obviously, is that you can feed data into the LCD twice as fast. But I got to be honest, we're only feeding 32 bytes of data into this thing. It's not like a big bottleneck to only have 4. And the obvious downside of having 8 pins is it's more of a hassle to wire it up. So we're just going to use 4 for our demo, but keep in mind that you can do 8 if you really want to. And then these last 2 pins, 15 and 16, these are the anode and cathode for the LED backlight in the LCD unit. As I mentioned, pins 1 and 2 are ground and power for the LCD panel, for sort of the upper portion of this hardware device. These are the ground and power for the LED backlight that's shining behind the LCD, right? So that's what all these pins do. 16 pins just to make a 32 byte character display work. It's a little bit complicated. What does it look like when we actually wire it up? Well, this is the circuit that we're going to be using for our examples today. As you can see, the pins are 1 through 16 laid out along the top here. It's plugged into this top row of my breadboard on the other side of the trench. So all of these tie points are electrically connected back to the pins in my LCD1602. Starting over here on the left, you see we've got a red wire and a black wire going back to our Arduino. That's our power and our ground. As always, those are feeding these 2 rails on the breadboard. The ground is blue, the power is red. And then the first thing we've got here is a potentiometer. Now we've used potentiometers in some of the earlier videos, but just to refresh your memory, potentiometer is a variable resistor. When we turn that knob, what that does is it changes the resistance value that is being sort of output from the device. So we have a ground pin on the far left here. That's what this black wire is, going back to our ground rail. We have a red wire for power going to the outside pin, going to the right-hand pin. And then in the middle, this third pin, this output pin, is looped over here to our LCD, and that's going into pin number 3. Now you may remember pin number 3 is our VO pin. That's our resistance to set the level of the backlight, or the level of the opacity in our LCD here. So really what this potentiometer is going to do is it's going to act as a brightness knob, right? It's going to adjust the contrast of our LCD to make sure that we can read it. There are LCDs that have this built in. We'll probably look at one of those soon. But for now, this is a manual thing. If you had a particular resistance level, you could probably use a static resistor for this instead of a potentiometer, but I'm going to use the potentiometer because it's easy to wire up. So that is plugged into pin 3 here. Okay, so that's this half of the board. As you can see from this sort of snarl of spaghetti over here, this is the more complicated side of the circuit. So let's take a look at this. Pin 1 is my ground, and we see here we got a black jumper going back to our ground rail. Makes sense. Pin 2 is our power. We got a red jumper going back to red. That's perfect. Pin 3 is VO. We already talked about that. That's this blue wire going back to our potentiometer. Pin 4, this is the register select. That's this green wire, and this green wire is going back here to pin 12 on our Arduino. It's just going back to a regular digital output. Pin 5 is just a ground wire. It's just a jumper back to the ground rail here. That's that read-write pin. Technically, the read-write pin should change function if you feed a high voltage signal into it. It is possible to address that read-write pin using the liquid crystal library, but it doesn't do anything. Like you can turn on reading from the device, but you can't actually read from the device. You can just toggle the mode on and off, and it doesn't do anything. So all I did was I jumpered it over to ground here to keep it at low. We're not going to need to use it, so that'll just keep it from causing problems. Next, we have our engage. That is this orange wire that's going over here to 11. And then after that, we've got our 8 data pins, right? So as I mentioned, you can feed data in a byte at a time if you use all 8 pins, 8 bits, obviously being a byte. Or you can feed data in using just 4 pins at a time, which is what we're going to do. So we're using just these 4 here. These 4 are empty, and then these 4 are plugged back here, and they're going to 2, 3, 4, 5, right? So these white jumpers here that are going to these 4 digital pins are coming back over here, and they're going to these 4 data pins. And then finally, we have a power and a ground jumper over here. Those are the ones that are powering that LED backlight that's behind the LCD panel. Right? So we've got 2 separate power connections and 2 separate ground connections for this LCD1602 unit as a whole. One pair is powering the LCD portion, powering the actual display matrix, and the other is powering the backlight. All right. So that's our wiring setup. It is a little bit complicated. And again, there are simpler versions of this LCD1602. I'll probably talk about that in a upcoming video, either the next one or one very shortly. But if you're just using a raw LCD1602 with a 16-pin interface, this is what the wiring is going to look like, because you need to wire up at least 12 of those 16 pins just to make everything work. Now, this is what it looks like when it's powered up. And we'll see this in a moment when I feed some code into this one. But I wanted to take kind of a close-up picture so it would be easier for you to see. As you can see, there are 16 characters across here and 2 rows, hence LCD1602. Right? 16 characters, 2 rows. Each character is actually a small matrix that is 5 dots by 8 dots. So there is a built-in font that is designed to use these matrices, right? That is sort of picked out on here. But with that said, it is also possible to make custom characters. So if you can draw something that fits into a 5-column by 8-row grid, you can load it into this LCD1602 and it will display it. So that might be helpful if you're using this as a output for some sort of device, right? Say you want to monitor something, and like a Castlevania health bar, you want to show a bunch of hearts and tick them away, right? Something like that. That's very easy to do. It's easy to make custom character sets with this. I'm not going to do it in this video, but maybe I'll do it sometime soon. Stick a comment in the YouTube channel if you would like to see me do that. All right, so that is our hardware layout. Let's see what the software looks like for this thing. So we'll start with this. This is a very simple Hello World program. We start by including the library, and I have not yet loaded the library on here, so let me do that. Liquid Crystal will install. Okay, so we've installed the Liquid Crystal library. We're using version 1.0.7. So we include liquidcrystal.h, that's the Liquid Crystal library. Then we create an LCD object. So if you go to the Liquid Crystal docs, depending on the number of arguments that you use, this will set up in different ways. So if you want to use that RW pin, right, you can add one more number to this. If you want to use 8 data pins instead of 4, you can add 4 more numbers mapped to those pins. And as long as you put everything in the right order, it'll figure it out. in this case, we're creating an LCD object. We're calling it LCD. And the parameters are what pin is the RS, the registry select, what pin is the enable, and what pins are data 4, 5, 6, and 7. So looking at our wiring diagram, register select is on 12, enable is on 11, and then our data pins are on 2, 3, 4, 5, right? So that all hangs together. That's all wired up the way that we want. So that is 6 of our pins, right? And then we've got 4 data pins that we're not using, and then we've got the power pins and the ground pins and the read-write pin, right? And that's everything. Okay, so then we move on to our setup. First, we set up the number of columns and rows. Again, this is a 1602 display, so 16 columns, 2 rows, 16,2, and then we clear the LCD screen. So we power it up, we set the number of columns and rows, we clear the screen, so there's nothing on it. And then we can go into our loop, right? So we're going to print a message to the LCD. Now, by default, after we run clear, the cursor, which is invisible by default, although you can turn it on if you want to, is in location 0, 0. That is to say, the first spot in the first row. Being good computer scientists, we always start counting at 0 instead of 1. So we're column 0, line 0. So what this is going to do is it's going to print a few spaces and then the word Arduino. Then we set the cursor to column 0, line 1, which is right here. And then we print another message to the LCD and we print for amateurs, right? So this should simply print Arduino for amateurs to our display. I have to be honest, I've been busy the last couple weeks. I set this up, but I don't know that I ever tested it. So let's see if it does what I think it should do. I'll plug in my Arduino here. I will hit upload. All right, and then if I hold this up to the screen so you can see it, I think my little box here isn't working as well as it once did. If I hold that up there, you can see it says Arduino for amateurs. If that's hard to see, I can adjust the contrast using the knob here. Turn that down a little bit so it's not quite so bright. And we'll see if that works for you. Arduino for amateurs. All right, so that is just a basic hello world, can I print text to this sort of thing. There are some text effects that are built into the Liquid Crystal library. So let me zoom over to my other program here. This is called LCD Marquee. If you are of a certain age, as I am, you remember JavaScript marquees in websites back in 1990 or something. So what we're going to do here is we're going to have some moving text. So it'll be similar, but just a little bit more interesting. So let me just turn that contrast back up here. So we include the library. We create our LCD object. Same thing. We've got our register select, our enable, and then our data pins. We set everything up, and then we print a message to the LCD. In this case, we're going to print scrolling text demo, and then delay for 1,000 milliseconds. So delay for 1 second. Okay, we upload this now. And then what our loop will do is it's going to use this built-in function called scroll display left. And it's going to scroll everything on the screen to the left by 1 position and just do sort of a scrolling marquee effect, delaying by 300 milliseconds in between movements. So if I hold this back up to my screen, you should be able to see the text scrolling by. Right, it says scrolling text demo, and it's scrolling right to left, moving 1 space every 300 milliseconds. So there are some other cool functions that are built in for doing text handling. You can scroll left, you can scroll right, you can turn on auto scroll, so as you write new things in there, it'll scroll things around and make room. You can turn cursors on and off. As I said, you can create new character sets. But this is really a super flexible little means of generating output from your device. You don't necessarily need to use the serial monitor or something like the NeoPixel ring. Instead, you can put a small display in your circuit, wire it up like this, and it will allow you to send text messages to the viewer or to the user, right? So you can make these circuits sort of autonomous rather than depending on them being connected to a computer that's running a serial monitor and so on. All right. So that is the basic function of an LCD1602. That's how it works. That's how we wire up our 12 or 16 pins and get data in there and see what's going on. I have another one of these LCD1602s that uses I2C, which is another communications protocol. The cool thing about that is it only uses 4 pins instead of requiring 16, so you don't have to basically eat up everything on your Arduino just to connect an output device. So I think I'm going to dig that out and talk about it in my next video. But until then, I hope this was useful. Have a great day.